Hi, good morning everyone. I'm Jinky and I will be presenting the Chapter 2 of Advanced System Design with Java UML and MDA. Now, what is Chapter 2 all about? Today, we are going to talk about UML. What is UML? U stands for Unified, M for Modeling, L for Language. The Unified Modeling Language is a general-purpose, developmental, and modeling language in the field of software engineering that is intended to provide a standard way to visualize the design of a system. It is a model or a visual language, or it was called a blueprint of a source code. To give you some background about UML, UML arose from 1980s and 1990s. It is a result of successful unification of many object-oriented analysis and design notation. UML was developed at Rational Software at year 1994 to 1995, with further development led by them through 1996. At 1997, UML was adopted as a standard by the Object-Oriented Management Group, or OMG, and has been managed by this organization ever since. A major revision of UML to version 2.0 was published at year 2004. And at year 2005, UML was also published by the International Organization for Standardization, or ISO, as an approved ISO standard. UML has different diagram or modeling notation. It has three groups: behavior, structure, and interaction diagram. Behavior diagram represents the dynamic aspect of the system. It emphasizes what must happen in the system being modeled, since behavior diagram illustrate the behavior of the system. They are used extensively to describe the functionality of the software system, while the structure diagram represent the static aspect of the system. It emphasizes the things that must be present in the system being modeled. Since the structure diagram represent the structure, they are used extensively to documenting the software architecture of software system. The last one is the interaction diagram. Interaction diagram is a subset of behavior diagram. It emphasizes the flow of control and data among the things in the system being modeled. For example, the sequence diagram shows how objects communicate with each other regarding a sequence of message. In Kevin Lanu's book, he identified 8 types of diagram that are use cases, class, object, state machine, communication diagram, sequence diagram, activity diagram, and deployment diagram. But he emphasized only 3 diagrams from 8 out of 8. These are the use cases, class, and the object diagram. Let's start on use case diagram. Use case diagram is a generalization of the scenarios of the use of the system. Technically, a scenario is an instance of a use case. Use case diagram has 4 major components. These are the system, actors, use cases, and the relationship. System represent a rectangle while actor represent a man. Use cases represent a oval shape, and the relationship represent a line connecting to each class. System can be website, software component, business process, application, etc. While an actor can be a person, organization, another system, or external device. Use cases is an action that accomplishes some sort of task within the system. and the relationships can be an exclude or extend. In this figure, it shows generic use case diagram, where actor A participate in two use cases, and actor B is one use case only. This is not part of the official UML use case notation, but can be helpful in including the intention to use the use cases. Below are the use cases additional textual description. Number 1 is the summary. It is a description of the purpose of the use cases. The second one is the start of the use cases, which is the trigger event. Number 3, end of the use cases, which is the termination event. Next is the interaction between the use cases and the actor. This identifies what activity should be inside the system and which should be outside of the system. Number 5 is the exchange of information. What data items are passed between the system and the actor? 6. Chronology and origin of information. It identifies when the system requires internal or external information and when it records it. 7 is repetition of behavior. 8 is an optional situation. It is a point where an actor or a system may choose different behavior within the use cases. The last one is the capacity. Number of concurrent execution of the use case that the system may have to handle. In this figure, it gives the use cases for a shared management system, where price changes are informed to the system from stock exchange, and the trader using the system may receive alert too from it when shared prices changes past some present limits. The trader can also use the system to sell shares. Trader is a primary actor that initiates the use of system, and it's always placed at the right side. While the stock exchange is a secondary actor that is always put at the left side of the system. For the use cases, it should be in a logical order. Use cases has includes, extends, and generalization relationship. For example, in this banking app system, there are use cases log in, check balance, transfer funds, and make a payments. All those functions are being done by the customer. Customer is a secondary actor, while bank is a primary actor. Customer has a relationship to use cases log in, check balance, transfer funds, and make a payment, while bank has a relationship to use cases check balance, transfer funds, and make payments only. Bank don't have relationship to log in because the trigger are processed at the system backends. Now, what is the difference of includes and extends? An includes relationship show a dependency between a base use case and an include use case. Every time the base use case is executed, the include use case is executed as well. Another way to think of it is that the base use case requires an include use case in order to be complete. When you have an include relationship, draw a dashed line with an arrow that points toward the include use case. So, on our example, login is the base use case, and verify password is the include use case. Every time the customer logs in a banking app, system will automatically verify password. This login use case won't be complete unless the verify password is complete. So we need to draw a dashed line within an arrow pointing towards the include use case and write the include. The next type of relationship is the extend use case. Relationship, I mean. An extend relationship has a base use case and extend use case. When the base use case is executed, an extend use case will happen sometimes, but not every time. The extend use case will only happen if certain criteria are met. When you have an extend relationship, you draw a dashed line with an arrow that points toward the base use case. In our example, login is the base use case, and the display login is the extend use case. The banking app won't display a login error messages every time a customers log in because it will proceed once login is successful. Since this is an extended relationship, we draw a dashed line with an arrow pointing to the base use case and write extend. Let me show you a very basic example to help differentiate between the two. If you sneeze, you will close your eyes. That's include the relationship because it's going to happen every time. Additionally, if you sneeze, you might say, "Excuse me." That's an extended relationship because it supplements the sneeze, but isn't completely necessary in the sneezing process. Just remember that include happen every time, extend happen just sometimes, and don't forget that the arrow point in opposite direction. The last type of relationship is generalization, also known as inheritance. When you make a payment from banking app, you can do so from either your checking account or your savings account. In this scenario, make a payment is a general use case, and pay from savings and pay from checking are specialized use case. You could also use the term parent and children. Each child shares the common behavior of the parent, but each child adds something more on its own. To show that it is a generalization, we draw this type of arrow from the children up to the parent. You can also have a generalization with actor. Here's the sample of person's generalization. In figure 2.4 shows an example of an actor inheritance. The administrator, actor, in an state agency system can perform all the use cases that staff can, but in addition, can modify staff's data as well. The next type of diagram is the class diagram. Class diagram are the most important kind of UML diagram and are vitally important in software development. Class diagram are the best way to illustrate a system's structure in a detailed way, showing its attributes, operations, as well as its interrelationship. Class diagram represent the classes, which is the type of objects, in the system together with the relationship that exists between them. Class diagram can be used at different stages of development, which is the conceptual modeling, analysis modeling, design modeling. In conceptual modeling of the problem's domain, possibly including entities that are external to the final developed system, but that interact with it. Analysis modeling is a recording in a precise but implementation independent manner, the agreed requirement of the system. The design modeling is the detailing the design structure of the system, dependencies between classes, etc. In this figure, it shows a very small extract from a class diagram of a Scrabble system, in which there are two classes, the letter and the bug, and the relationship between the bug and the letter. It represents the fact that between 0 to 100 letters may be contained in the Scrabble bug at any point in time. This simple model has four kinds of elements on it, which is the classes, relationship, attributes, and the constraints. And also, a multiplicity indication between bug and letter. Four kinds of elements of a class are a classes, attributes, relationship, and constraints. Classes represent as a rectangle with the name of the class at the top of the rectangle. Class names are normally written in boldface, begin with a capital letter, and are centered in the rectangle. Attributes represent inside the box of the classes to which they belong, and written as name semicolon type, where name is the attribute name and type is its type. For example, symbol is an attribute of letter describing the printable character of the letter, and so it has type car. Attribute name should start with the lowercase letter. Next is the relationship. It represented as line between classes. The UML term for the simple form of relationship shown here is association. Last type, last element is the constraints, written in a dog-ear boxes and attached to the element they contain by dashes lines. Constraints give detailed properties that the model is intended to satisfy. There are different relationships in a class diagram. One of these is the generalization or the inheritance, known as an is-a relationship since the child class is a type of a parent class. Generalization is the ideal type of relationship that is used to showcase reusable element in the class diagram. Literally, the child classes inherit the common functionality defined in the parent class. Next is the association. An association relation is established when two classes are connected to each other in any way. For example, A bank registers account. Association can be shown as follows. The third one is the aggregation. When a class is formed as a collection of other classes, it is called an aggregation relationship between these classes. It is also called a has-a relationship. The next one is the composition. The composition is a variation of aggregation relationship. Composition illustrates that the strong life cycle is present between the classes. Last one is the multiplicity relationship. An example of this kind of association is many accounts being registered by the bank. Hence, the relationship shown as star sign near the account class, one to many and many to many, etc. When it comes to class diagram relationship, this is one of the most misunderstood relationships. Here's some multiplicity constraints and standard notations of UML. Asterisk means any number of objects allowed, including 0. 1, that asterisk, at least one object, or one to many. 1, exactly one object. N represent exactly n objects or specific number. A to B, at least A, N, at most B. So, it is a specific number range. 0 to 1 is an optional. 0 to asterisk is 0 to many. In figure 2.8, it gives an example of a situation that satisfies this diagram. There are 5 persons, of which person 5 and person 1 are their own boss. Person 2 has a boss, which is P1. And person 3 and person 4 has a boss, which is P2. Person 5 works for a company 2, and other works for a company 1. The arrow points in the direction of one multiplicity association ends. In addition to attributes, classes may have operations or methods. The attribute and methods together make up an explicit features of a class. Operations are used to specify the behavior of objects of a class. In particular, how they respond to events or message directed at them. Operations are listed in the section of the class rectangle beneath attributes. Now, let's try to check what are some different behavior of this animal class, which is the zoo system. Example condition is we want to change the name of a pig to Anna. So, we need to create a function called setName. Methods also need to be formatted as in a certain way. You start with visibility, then the method begins with the lowercase letter. Next, you put parentheses to signify the functions you're going to program later. And we could also create a method for eating since all of the animals eat. There are different types of visibility in a class diagram. The visibility of an attribute or a method set an accessibility for that attribute or method. The first one is the negative sign, which means private and can't be accessed by any other class or subclass. The next visibility is the plus sign, which means public and can be accessed by any other classes. Then, next is the hashtag, meaning the visibility is protected. It means attribute or method are protected and be accessed only by same class or its subclass. The last one is the package default or the style design. Means can be used by any other class as long as it is the same package. Here is an operation example. Operation name are usually written with an initial lowercase. Operation can be either a query if they do not modify the internal state of the object or update if they do. Query operation declaration can be written with a query constraints beside them on a class diagram. An operation can have input parameter which supplies information to it. A query operation usually returns some properties of an object state and is quite similar to a derived attribute in this respect. An operation can have input parameter which supplies information to it, and any of information parameter can be listed, although it is usually good practice to try to minimize the number. Class diagram can also have enumerations. Enumerations are model element in class diagram that represent user-defined data types that consist of a set of name values that represent integral constant known as enumeration constant. An enumeration is a simple enumerated type such as on-off for the set of state of a switch. It is represented as a rectangle in a class diagram with stereotype enumeration and with its value listed. This figure is the sample of illustration of an attribute with enumeration. Enumeration is a kind of list table. Like in this sample, the data types are integer, string, XML, double character. So we have the type of value type, which is the array, fields, like that. So the other type is the on and off, and also female or male. And the data types distinction, integer, character, double, string, XML. So basically, those lists can be put also in a text box of the application. To summarize, enumeration is part of a class. It was pointed to attributes or a method. Associations has two types, ordered and qualified.
The end of an association may have an annotation ordered beside it. See figure 2.17. If the multiplicity at the end is not 1, the ordered annotation means that the set of objects at the roll end have an ordering on them. Example, they form a sequence instead of an ordered set. Duplicates are not normally allowed in such a sequence since association links are considered to be uniquely defined by the pairs of objects that they connect. An ordered association and can be true of as an array or list. The elements of a sequence occurs in a definite order and can be referred to by their index in this order. In particular, the value of r.rank letter for a rank r is a sequence. The letter occurs in some order, left to right on the rank. Our notation for accessing the first elements of a sequence is r.rank letters and r.rank letters 2 for second, etc. Also be qualified, which means that they act like map from a certain set of features values, together with an object at one association end to identify an object or set of objects at the other end. For example, each square on the board of the Scrabble game has a unique x and y coordinate pair. So this can be used given a board object to specify the square. Figure 2.18 shows the notation for this given a board B, and x is to 1 to 15, y is to 1 to 15. The sequence with these coordinates is referred to as a B.board squared, x and y. If a qualified association rule is used without qualifier values, then all objects associated at the roll end are returned regardless of index value. Thus, B.board square is the set of all squares on the board B. Similarly, for ordered association.
The last diagram that I will discuss is the object diagram. Object diagram are derived from class diagram, so object diagram are dependent upon class diagrams. It represents an instance of the class diagram. It also represents the static view of the system, but this static view is a snapshot of the system at a particular moment. Object diagrams are used to render a set of objects and their relationship as an instance. What are the purpose of the object diagram? The purpose of the object diagram should be understood clearly to implement it practically. The purpose of object diagram are similar to class diagrams. The difference is that the class diagram represents the abstract model consisting of classes and their relationship. However, an object diagram represents an instant at a particular moment, which is concrete in nature. In this figure, it shows that the matstat is the instance name of the class department. So this is the sample of object diagram. If you want to more about UML, please use below references. That's being used also on my presentation.
And also, here's the definitions that being used in my presentation. UML is Unified Modeling Language. OMT is Object Modeling Techniques. OOSE is Object-Oriented Software Engineering. OMG is an Object Management Group. OOP is an Object-Oriented Programming. OCL is an Object Constraints Language.
End of my presentation. Thank you for listening, everyone. See ya!